Okay, good morning students. So yesterday previous class we learned about introduction of mechanical properties of fluid, in which there are two parts. We said that in one of the part we said that part 1 mechanical properties of fluid, part 1. Under the part 1 many things I wrote it on yesterday. So those are all the topics we are going to cover. So in which so far we covered about what is a fluid, what is the density. Okay, in the same manner we learned it about mixture of densities. We learned it about pressure, atmospheric pressure. Okay, some of the problems we did it, the atmospheric. Then also we learned it about barometer. Okay, in the barometer, if you are taking water, then what will happen, how much length of the tube we have to take. These are all the things we learned it on yesterday very clearly. Hoping that you understand yesterday's class. Let's we can start with a monometer. Okay, then we can go for the example problems. Let's see here, monometer. Okay, monometer is an instrument which we are used to measure the gas pressure. Okay, so here, so monometer will be an, see here, this is the construction of monometer. Okay, for this is totally filled with the gas. Okay, so it is a cylinder. Okay, for this cylinder we connected for one U shape of tube. Okay, like this. So this is a U shape of tube. One of the end it will be an open. Okay, here this tube will be filled with the mercury. Okay, let it be, the mercury is there up to here. Now here there is a wall. So now the height of the mercury, let it be, now this is the construction of manometer. Let's know what will happen here. Once we remove this stopper, then what will happen, this gas will be comes out from the cylinder and it will make a pressure on the mercury column. So once it is make a pressure for the mercury column, let's consider this gas will be comes up to here. Okay, now the other end, the second column of the mercury tube, the mercury will be rises up to here. Let's consider here we have a meter scale. Okay, measurement scale will be there here, so we can easily measure the height. So here there is a scale is arranged to measure the height of the mercury column. Now if you are taking these 2 points, okay, these 2 points, let's consider this is the point A and it is a point B. So at the horizontal level, both the point pressure is an equal. So now that means to say that PA is equal to PB. So here PA is nothing but pressure of the gas, is it not? So here this is a pressure of gas, PG is equal to, okay, now this is equal to PB. What is the PB value here? Let it the rho Hg, mercury column. So rho Hg, right, into G, acceleration due to gravity, into height. Let it be this height is an consider as an H height. Okay, so rho G H. Understand? So rho is belongs to mercury, is it not? So now this is an open end, SN. Here the atmospheric pressure will also be at, so that's why we are taking as an P naught. Are you getting my point? So P net is equal to, now let it be P net. P net is equal to rho GH plus P naught. Are you getting my point? So rho GH plus P naught. This total, see here, this total pressure we can call as an absolute pressure. This total pressure is called as an absolute pressure. Only the pressure which is exerted by the gas is called as an gauge pressure. Okay, gauge pressure. Are you getting my point? So the pressure existed only by the gas is called as a gauge pressure, and total pressure we can call as an absolute pressure. Okay. So let's see, we'll take some of the example problems here and we can move on to the continue of our lesson. Okay. Hope that you understand well about the manometer. Is a simple instrument which will be used to measure the gas. Okay, gas pressure. Now, see here. For example, let it be this is the container. In this container, there are two liquids are there. Okay. So this is a rho. The second liquid is an considered as an 2 rho. Okay. The length of the second is an, let it be considered this is an H1 and this height is an H2. Now what is the pressure here? Pressure at a point P. How much, my dear? It is an pressure by the both liquids. Yes or no? So that means to say that, so it is an open container. First it will come as an P naught. Atmospheric pressure will be there here. Yes or no? This is an atmospheric pressure P naught plus pressure due to first liquid, that is rho G H2 plus rho, that is second liquid term is an 2 rho G H2. Simple. This is a P net. Okay. P net at a point P. Are you getting my point? Do you understand very clearly?
Yes, sir.
Okay. So can you please copy this? Then we can go for the next one. Shall I write this now?
Yes, sir.
Yeah. If you take 3 liquids, doesn't matter if you take 4 liquids, whatever it may be. So we can easily find out the pressure exerted by the liquids. Yes or no? Okay. So now, let's consider there is an, okay, here, see, let's consider like this. So now, this is an tube is there in this manner. Okay. So now here, this one liquid is filled completely. Okay. So totally liquid is filled here. So let it be consider this height is an H height. Okay. This is also, otherwise consider as an H1. This is also H1. And now this height is an H2. Okay. Now what is the pressure at this point? What is the pressure at this point? Let if you want to find out the pressure at this point. Okay. So we know very well. So now how can we find out the pressure at this point? We know very well. See here, the pressure at this point is, first it is an P naught. Yes or no? P naught plus, see here, let it be, the density is an rho, first is an rho G H1 up to this point. Okay, rho G H1. So once comes here, it is also rho G H1. Once we go up, then what will happen? The pressure will be decreases. Yes or no? How much? Rho G H2. Is it not? Rho G H2. This is the pressure at this point. Yes or no? That means total is an P naught plus rho G H1 minus H. Are you getting my point?
Sir.
Right. For example, if we take another example. Okay. For example, if this total instrument is given like this, let it the angle is an 60 degrees. Then what will happen? It will come as a cos theta. The height will be cos theta. Yes or no? For example, let's consider. See here, if the liquid column is moving there like this, okay, making it the angle theta. Okay, this height is considered as an H height. Now, how much pressure will be exerted? What is the pressure will be exerted by the liquid at this point, bottom of the point P. Okay, let we can write P net is equal to first P naught plus rho G. It is not a H. Yes, if it is on straight perpendicular, if it is on perpendicular, then we can able to write the H. But it is on, I am making the angle is theta. Are you getting my point? Yes, sir. So now vertically we have to take. Yes, sir, vertical. So if it is on theta. So now what will happen? See here. So if it comes to the vertical, for example, consider this angle is a theta, okay, vertically. Then what will happen? H cos theta will come here. Are you getting my point? If it is a theta is taken here, then we can also be take as a sin theta. Are you getting my point? So easily we can able to write. So if the structure is given in the form of triangle, then also we can be able to find the pressure at the bottom of the point very easily. Are you getting my point, everyone?
Yes, sir.
Yes or no? Okay. So then we can take some example problem for U shape. See here. Now let it be. There is an U type, U shape of liquid columns are there. Okay, like this. Now this total liquid, okay, it is filled with the, see here, let it be, we can take as an, here there is a stopper is there. One of the limb will be filled with, okay, the density of 2 rho, and the same height we can take the density of the liquid is rho. Okay. Now both the heights are considered as an, let it be this one h, and it is also h. Okay, h height is there. Okay, consider h height and h height is there. Now what will happen if once the stopper will remove, then what will happen? Due to the 2 rho density, the density of this liquid is more than the density of this liquid. So what will happen? This liquid will be give the pressure to the liquid rho. Then the liquid rho will be rises. So how much it will be comes down, that much is rise. Yes or no? The final structure will become like this. Yes or no? So here it will come like this. Okay. So now let it be consider this x. X height will be comes down. That means this total height is how much, my dear? H minus x. Okay. So here is the stopper. Now stopper will become here. That means here it is an, this liquid will come as an x. It is an 2 rho. Now 2 rho liquid will becomes here. It is already, so up to here. So this total liquid height is an, we already said that is an h. So this is an x. So here 2 rho. Yes or no? Now what is the pressure? So now what we are going to do? We are going to take the horizontal point, and here is the point A and point B. So once PA is equal to PB, okay. So the question is asked, how much height is raised in the left column, okay. So we can find out the x value here very easily. So see here PA. If you want to write here the pressure, first is the P naught plus, due to this rho liquid column, rho GH plus, due to this liquid column 2 rho x is equal to, here this one 2 rho G H minus x, is it not? So plus P naught this side. Understand? So P naught get cancelled in the same manner. Rho G, here also rho. Okay, here also G will be there, right? So G, this G will get cancelled. This rho will get cancelled. Yes or no? Now what is here? H is remains here. H plus 2x is equal to, here 2h minus 2x. This 2x will comes, this side is becomes as 4x is equal to, 4x is equal to h, x is equal to h by 4. So this is the value of x, which is rises in the second column. Okay, are you getting my point? This much the height is rises by the rho density of a column. Are you getting my point? So like that, if you want, we can take as 3 liquids, 4 liquids, 5 liquids, whatever the liquid. But we have to understand how to write the pressure at the same level. Are you getting my point? Let's write it down. Then we can go for the many examples. Okay. Okay. If you want, we can take the 3 liquids. Okay. Then also we can be solve very easily. Let me see. I will take one example for the 3 liquids, and we can able to solve the problem. Okay. See here. Let's consider. Okay. Now here is the stopper. Let's here also is the stopper. Now this total liquid is filled with. Let's consider a 2. Now this total liquid filled with 3 row. Let's the same idea we take as an this liquid is filled with, okay, example. So now once the stoppers will remove, then what will happen? It will the 3 row density will be make a pressure onto the row 2. Row 2 will make the pressure on row. Then he has the what is the height rises by the liquid column row. Okay. So easily. So the final stage how it will come? Let it be see here. This is the final. Let's see. Once the stoppers will remove, then what will happen? Let it be considered. It will comes here. So that means from here to here, x length is comes down. Consider. So this height is considered as an L. This height is also considered as an L. Okay. This is also considered as an L. Then what will happen? It will come to up to here. Then it will be rises. This is an row. Height is L. Okay. So here this height is L. Now this 2 row will goes up here. This total liquid is okay row L, and this will become as an 2 row. So 2 row is height is rises as an x, and now this total is it is an 2 row only. This is also a 2 row. Okay, up to here this rises. Okay, this total length is L minus x. Okay, so this is an L minus x. Okay, now this is an how much it is 3 row. Then if you take this horizontal level, let it be this is a point A and it is a point B. Then first P naught plus due to this liquid column rho GL plus due to this 2 rho GX, okay, is equal to this side P naught. Understand? This side is an P naught plus 3 rho G. How much we took as L? So that means L minus X. Okay. So P naught get cancelled. Rho G get cancelled. Then what is the value which remains here? L plus X. Yes or no? L plus 2X is equal to 3L minus 3X. The X will come this side. So 5X is equal to 2L. X is equal to 2L by 5 is the answer. So this much of height is rises in the second column. Are you getting my point? Like the 2, 3, 4, how many we want, we can be take and we can easily solve the problem. Okay. Can you please make it note it down? Then we can take one example. Okay. See now, do you want more examples or is it enough? Okay, one more example. Let's see. This example you have to do by yourself. Okay. Do this problem very carefully. Okay. See, a vertical U-tube. See, consider this is an U-shaped tube. Okay. Initially, there is a mercury is there. Okay. Initially, the total mercury is there here. At the same horizontal level, mercury is there. Okay. Now what we did? In this mercury we know that the density of the mercury, which is equal to 13.6 gram per cc. It's given. Okay, 13.6 gram of cc. Initially it is filled with the mercury with the same horizontal level. Now what it says, we are introducing the glycerol. Okay, we are introducing the glycerol. Okay, and the glycerin we fill with the 10 centimeter. Okay, how much? 10 centimeter with the density of glycerin. Density is 1 point. So let it be. Density of glycerin is equal to 1.3 gram per cc. Now in other column we introduced the oil. Okay, oil. Here is glycerin, that side is an oil. So the question is, how much oil should be added to the other end of the column such that the glycerin, that means the surface of the oil, will come same height with the height of the glycerin. H. We have to find out H. How much height of the oil has to be added to the other end of the U-shaped tube such that this oil surface will come equally to the surface of the glycerin. Are you getting my point? That is the question. Can you please do it by yourself? Okay, do it by yourself. Yeah, do it. Okay, you want oil density? Okay, no problem. Rho oil is equal to, let's consider as an, how much you can take? 0.8. Can you take 0.8? Okay. Take as an 0.8. 0.8 gram per cc. Now you can do. Yeah, do it. Okay. What is the value? Is the value will come? Steady again. Do fast. Do fast. Okay. See here. So if you take this horizontal line, okay, let it be, this is the point A and this is the point B. Now, so PA is equal to PB. P net, this arm is a P naught plus. This is total is a, see here, rho 1.3 into rho G. We can take as a G into height is an 10. That is equal to this side. How much it will be? See, it is an consider this is total is an height. Initially it is an H. Then now this an height we have to find out. So let it be this an 0.8 into H into G. Okay, rho G H plus due to this. Okay, this is on 13.6 rho. Okay, this one. Then G into this one 10 minus H. So how much it will be? 10 minus H. Okay, it is on 10. See here, 10 minus H is equal to this side will come. Yes or no? This total height is on 10. So this side is on H. Okay, this side will come as a 10 minus H. Are you getting my point? Understand? So that is the equation. If you solve this equation, whatever the value will come, that is the value of H. Okay. So here, this side also P naught will be there. P naught get cancelled. Okay. G get cancelled. Okay. How much remains here? So 1.3 into 10. So that is then 30 is equal to, how much it will be? 0.8 H plus, okay, 136 minus 13.6 H. Okay. So 13.6 H, 0.8 H. How much it will be? Okay, this total, if we take this side, it will be 13.6 H minus 0.8 H. Okay, otherwise take the H common. Now is equal to 136 minus 30. Okay, are you getting my point? Do you understand? So how much it will be? This is 3. Okay, it is 2. It is 1. Now here 0.6. That means to say that here H into how much it will come? So 8 8 point, here it will come as a 2, it will come as a 1. Okay, so this is the value. So h is equal to how much, my dear? H is equal to 123 upon 12.8 is equal to h. Whatever the value will come, that is the value. It will come approximately 9.6 centimeter. Okay, approximately. So 9.6 centimeter. There is the answer. Okay, got it? I hope that you understand. However the question will give, we can able to solve the answer. Is it not? That's it. Are you getting my point? Please make it note down this. Then we can continue the lesson.